Hi students, I hope you are doing well. Okay, today we are going to discuss a topic from number system, okay, which is like how to solve the, how to solve a rational number, operational rational numbers. Especially this concept is operational. Not only rational numbers, we are going to operate, do operations on real, like rational numbers also. This is considered as operational real numbers. And we already discussed in last video related to this, how we did, like addition of real numbers, subtraction of real numbers, and some more problems we are going to discuss today. And also, we are going to discuss a very important topic, which is rationalizing the denominator. Okay. So, this is the continuation of the last, whatever the last video. Okay, the first sum. See, the question is classify them as rational or irrational. It means we have to check whether this number is a rational number or an irrational number. One basic thing you have to understand. Again, this is repeating, which is very important. A number which a rational number added to an irrational number, a rational number subtracted to an irrational number with an irrational number, or divided with an irrational number, or multiplied with an irrational number, most of the times you will get an irrational number. You remember that. Okay. Some cases you will get rational number. Thus we will discuss in this. Okay. First sum, and you might be knowing what is a rational number, right? And what is an irrational number. A rational number is a number which can be written in P by Q form. An irrational number is a number which cannot be written in P by Q form. Okay? And also, a rational number is a number where you will get the decimal expansion of the rational number as terminating or repeating. Correct? Rational number's decimal expansion is either terminating or non-terminating and repeating. Correct. Irrational number decimal expansion is non-terminating and it is non-repeating. Okay. You have to remember that. So first we have to check whether this 2 minus root 5 is a rational or irrational. So solution for that is 2 minus root 5. Correct. So what is the root 5 value? Remember, root 5 value is 2.232 ... It means so on. Just an approximate value. So 2 minus 2.232 ... means so on, which will give you 0.232 ... Correct? That means decimal expansion is still there. Correct. So 2 is a rational number. Actually, we'll get minus here because 2.232 is the higher value. So 2 minus 2.32 is minus 0.232. Correct? So in this case, here we got a rational number subtracted from an irrational number. We are getting an irrational number. How can you conclude that this is an irrational number? You see the expansion. You see the decimal expansion. It is not ending. So you are getting, we got a non-terminating and non-repeating. Correct? It is not even repeating. See, any number is repeating twice. Repeating in the sense, see, maybe after this you will get 1, after this you will get 4. So, example I am giving you. After 2 we got 3, again 2, again 1. There is no any order over there. Okay, so definitely it is a non-repeating decimal. So if any decimal expansion is non-terminating or non-repeating, it is considered as irrational. So this number, whatever it is given, 2 minus root 5 is an irrational number. Okay, we classify this as irrational number. Correct? I'll just explain once again. The number which we have to classify, whether the question is we have to check whether these given numbers are rational numbers or irrational numbers. So 2 minus root 5. So 2 minus root 5. What is root 5 value? Approximately root 5 value is 2.231 or 2.232. Approximate value as I told. So in this 2 we are subtracting 2.232. You will get minus 0.23214 dot dot. That means decimal expansion is still there. We just put dot dot. So we got a non-terminating and non-repeating decimal. This decimal is non-terminating and non-repeating. As we know that if a decimal is non-terminating or non-repeating, that is considered as an irrational number. So 2 minus root 5 is an irrational number. Okay. Yes, let me solve next one. The next one is 3 plus root 23 minus root 23. This is very simple sum actually. 3 plus root 23 minus root 23. Okay. There is nothing logical in this. Correct? Because one is plus and another one is minus. So what do you get? 3. So 3 is obviously a rational number. So we classified this as a rational number. Okay? Understood? It looks very easy. Just see, as I said before, what I was saying, any number, okay, any number added means an irrational number added with a rational number should be an irrational number. But in this case, here we added with two irrational numbers. Means one we added, one we subtracted. Correct? One irrational number is root 23. Another irrational number is also root 23 only. But both I added and subtracted. So what happens? Any number, for example, here for 2, I added a and subtracted a. What do you get? A and a will get cancelled. You will get 2. Similarly, here we are adding and we are subtracting. What does it mean? Same number we added and same number we subtracted means nothing we are doing. Correct? We are adding and subtracting means it will become 0. You will get the same number back. So in this case, root 23 and root 23 will get cancelled and you will be left out with 3, whereas 3 is a rational number. So we classify the second one, 3 plus root 23 minus root 23 as irrational number. As I told you, some cases it will be a rational number. Example, one more example I will give. Take the same kind of root 23 itself. Say I multiplied root 23 with root 23. Okay. In this case, you see, root 23 multiplied with root 23, same irrational number we are multiplying. Okay. Root 23 is an irrational, again root 23 is also irrational. Both if you multiply, it becomes root of 23 whole square. Square and root will get cancelled. You will get 23. Correct? And all of you know how that square and root will get cancelled. See, because I'll explain that root 23 can be written as 23 whole power 1 by 2. Remember, root 23 is same as 23 power 1 by 2. So when you write 23 power 1 by 2 whole square, it will become 23 whole power 1 by 2 into 2. Because you might be knowing a formula, a power m whole power n is equal to a power m into n. We are just following that. Okay, root 23 I written as 23 whole power 1 by 2. So 23 power 1 by 2 again square is as it is we retain. Here we followed that formula, a power m whole power n is a power m into n, which is 1 by 2 into 2. 2 will get cancelled. You will be left out with 23. That is why root and square will get cancelled. I hope you understood this. Let me explain once again. Root 23 into root 23. It is, common for all. It may be root 2 into root 2. It may be root 4 into root 4. It may be root 5 into root 5. For all kind of, irrational numbers, multiplication, when you are multiplying same irrational numbers together, this, method remains same. So, root 23 to root 23 can be written as root 23 whole square. Root square and root will get cancelled. You will be getting 23. This is actually answer. So you might be having a doubt how root and square will get cancelled. That is that clarification I am giving here. What is that? Root 23 can be written as 23 power 1 by 2. Correct? So 23 power 1 by 2. 23 power 1 by 2 in the place for root 23 I written 23 power 1 by 2. Anyway, square is the square already achieved. Correct? retain. So we have a formula a power n whole power n is equal to a power m into n. So that's the reason 23 power 1 by 2 into 2. This 2 will get multiplied. This you take the m, this you take the n. So 1 by 2 into 2. 2 will get cancelled. You will be left with 23 power 1, which is 23. That is how you got 23 answer. Okay. And let me take one more example here. See, the last case we multiply root 23 with root 23. So both are irrational numbers. If you multiply irrational numbers, we are getting a rational number, which is 23. And for example, root 2 into root, we will consider it as root 18. No, root 2 only will consider, which will be root 4 whole square, which will be 4. Correct? So any examples, if you keep on giving examples, lot many of them. Got it? So if you multiply, sometimes you will get most of the cases, if you multiply an irrational number with the same irrational number, for example, root 2 with root 2, root 3 with root 3, root 5 with root 5, definitely it will become a rational number because square and root will get cancelled as I explained you before. Okay? So in this case, 3 plus root 23 minus root 23 will be 3 because root 23 and root 23 will get cancelled. Correct? Because both are of different size with the same value. So definitely it will get cancelled when 3 is a rational number. So we classified 3 as rational numbers in this case. I hope you understood this. Because this is the easiest one. This is I think no more explanation for that. Even this third one also, it is easily understood. Third one you see. 2 root 7 divided by 7 root 7. As we discussed in the previous video, 2 root 7 can be written as 2 into root 7 and 7 root 7 can be written as 7 into root 7. This is also simplest one. Root 7 will get cancelled. You will be left with 2 by 7. Okay? Root 7 will get cancelled. You will be left with 2 by 7. So 2 by 7 is what? It is in P by Q form. So 2 by 7 is an rational number. So 2 by 7 is a rational number. So we classified 2 root by 7 by 7 root 7 as a rational. Okay? It's very simple. I'll just explain once again. 2 root 7 can be written as 2 into root 7. 7 root 7 can be written as 7 into root 7. So write it. Root 7 is same. Just cancel it as we cancel in the normal multiplication. So just division. You cancel it and you will be left with 2 by 7. That is 2 by 7 is what? It's an irrational. So we classified this third one as rational numbers. So in this, I can write first one is irrational. First one we classified as irrational. Second one we classified as rational. And third one is also rational. So in this, 2 rational numbers are there and 1 irrational number is there. Okay, I hope you understood this. Let me go with the next concept. This is very important, okay, because this you will get in your higher classes. Even in 10th you will be using this concept. You will be using this in even 11th, 12th, first PU, second PU, and in higher even degree. So it's a basic concept. It's just like, for example, if you learn tables is important everywhere, right? Whenever you do multiplication without tables, you cannot do any multiplication. So like that, this is a basic thing. Rationalizing the denominator is the basic thing which you have to know. Okay, it will help you in further studies also. Okay, what is this rationalizing the denominator? What is this concept called rationalization? Remember, rationalizing in the sense converting a given number, especially rationalize in the sense what? It is not a rational number. See, 1 by root 2 is not a rational number, correct? So we are trying to put in a form, okay, as a rationalization, means we are going to convert into a form where it can be like, converted into a rational number. It cannot be converted into a rational number. We will just try to show it as a rational number. Okay? And don't get confused with this and all. Rationalizing in the sense, okay, one thing you have to understand, here 1 by root 2 is there. So you can ask me, why can't you keep like that? Why to rationalize? Remember, irrational number cannot be in the denominator. Root 2 is an irrational number. That root 2, you can never put root 2, not only root 2, any irrational number should never be put as a denominator. It can be a numerator, no problem, but it cannot be, put, or you cannot leave that in the denominator. You have to make this root 2 or any irrational number. This irrational number, root 2 is an irrational, that should be in the numerator. That is correct. Okay? For example, if you have root 3, yes, no problem, root 3 is correct. Root 3 can be done root 3 by 1, which is a irrational number. So 1 by root 3, that is not the correct way, because root 3 is an irrational number which is there as a denominator. In this fraction, root 3 is there in the denominator, so it should not be there in the denominator. We have to do something, some process or some calculations or some simplification for that to make it root 3 as a numerator. It is very simple. I will just explain you. I hope you understood why I am telling this, because always remember, any irrational number cannot be there, should not be there as a denominator. If it is there, it should be as a numerator. If it is not there, we have to convert. That process is called rationalization. We are converting, we are doing some simplification to get this denominator, which is an irrational number, to the numerator. See how we are doing. I just multiply with root 2 and root 2. This is nothing but we are rationalizing the denominator. What we are doing? We are rationalizing the denominator. What do you mean by rationalizing the denominator? We are converting the numerator into rational number. That is, denominator into rational number. That is the meaning of rationalizing the denominator. Means we are converting the denominator, which is root 2. Okay, that we are converting into a rational number. How we are converting? We are just multiplying with the same value. If it is root 2, multiply with root 2. If it is root 3, multiply with root 3. Then only, as I told, it become root 2 whole square, you will get a rational number. So, I am just multiplying with root 2. Remember, in mathematics, if you multiply this number with a number for denominator, the same you have to do for numerator. For example, 2 is there. If you multiply with 3 and leave it, is it correct? Right? You will get 6. We have 2 before. How it is correct? So, when you multiply with some number, you have to divide with the same number. So, what happens? 3 and 3 will get cancelled, you will get 2. So, that is correct. Original value you are getting back. If you just multiply with 3 and leave, it will become 6. So, 6 is not correct, because before it is 2, now we are getting 6. So, you are changing the number. It is mathematically incorrect. So, if you are adding a number, you have to subtract with the number. You are multiplying with the number, you have to divide. That is the mathematical rule. Similarly, here I multiplied with root 2, so I am dividing with root 2 also. So, when you do that, what is happening? You have to write here rationalizing the denominator. Okay, so it becomes numerator you multiply 1 into root 2. Okay, it's 1 root 2. Root 2 into root 2, which is root 2 square. Square root will get cancelled. That's the reason I explained you in the last term how this root 2 into root 2 will become root 2 whole square. So square and root will get cancelled. Root 2 by 2. That will be the answer. Here we clearly say that root 2 is there in the numerator. So before it was in denominator, right? We converted the root 2, which is an irrational number, which is in the denominator. We converted back and we made it to, we do some calculations and we made this root 2 to come as a numerator. So we got it as numerator. So this is perfect form. It can be root 2 by 2, but what I said, it cannot be as 1 by 2. Okay, your root 2 will never should not be in the denominator. Okay, so I'll explain once again. 1 by root 2 we have taken. What we are doing, we are rationalizing that thing. Okay, so what is the rationalization means? We are making this root 2, which is in the denominator, to come as a. So don't think rationalizing means we are converting 1 by root 2 as a rational number. It is not possible. 1 by root 2 we cannot convert into a rational number. That is already irrational number. Irrational number cannot be converted to a rational number. Okay, understood. We can try to make this irrational number part into, we can convert as a rational number. That's secondary. But rationalizing in the sense, this concept is not exactly making an irrational number into a rational number. That is not correct. Okay, rationalizing in the sense we are making the irrational number which is in the denominator to come as a numerator. That's all. Okay. So what I did, 1 by root 2, I multiplied with root 2 and divided with 2. As we know that we can multiply with one number means we have to divide with the same number. So we did it. And 1 into root 2 is root 2, and root 2 into root 2 whole square. As we explained in the last problem, root 2 and the square will get cancelled. You'll be left with 2. Your answer is root 2 by 2. Okay. Remember here I rationalized the denominator. Means I converted only the denominator to rational number. That's the reason it is rationalizing the denominator. Rationalizing the denominator means we are converting the denominator into a rational form. Numerator is irrational. Okay. So we got answer as root 2 by 2. Okay. I hope you understood. Next, we will go with the next term. 1 by 2 plus root 3. Okay. 1 by 2 plus root 3. Here also, see 1 is a rational number and we have denominator, we have 2 plus root 3. Again 2 plus root 3 is an irrational number, which is there as a denominator. So that should not be there in the denominator. We have to make it to come as a numerator. Correct. So rationalize the denominator. So obviously, we have to rationalize the denominator. Here, you remember one thing. Whenever you are rationalizing, okay, you have to think I erase this. So 1 by 2 plus root 3, we are rationalizing the denominator, right? Denominator rationalization in the sense, in these kind of terms, you have to understand if it is 2 plus root 3, okay, always you should be very clear with this. Whenever you have 2 plus root 3, you have to multiply with opposite side. If you have 2 plus root 3, you have to multiply and divide. As we know that we cannot just multiply and leave, we have to multiply and divide. Both we have to do. So we are multiplying with 2 minus root 3 and dividing with 2 minus root 3. Okay? Then if you have 2 plus root 3. Here what is the sign? We have plus. So we are taking minus. Don't change this 2 and root 3. Let it be. 2 and root 3 you cannot change. Same numbers. 2 and root 3, 2 and root 3. What you are changing? Only the sign. Plus you are changing it to minus. And you are multiplying with that number and dividing also with that number. So 1 into 2 minus root 3, which is 2 minus root 3. This will become 2 plus root 3 into 2 minus root 3. Correct? 2 plus root 3 into 2 minus root 3. And we know the formula a plus b into a minus b. Now we studied as x plus y into x minus y, same as a plus b. So we know that a plus b into a minus b is a square minus b square. So take this as a, take this as b, okay, which will give you 2 minus root 3 divided by a square, which is 2 square minus root 3 square. So 2 minus root 3 divided by root 2 square is 4, root 3 square is 3. So answer will be 2 minus root 3 by 1, which is 2 minus root 3. So we converted the denominator, which is as an irrational number, we convert it to the numerator. We send it to the numerator. So, but here denominator is irrational, but there you see denominator is rational, because we can write 2 by 3 as 2 minus root 3 by 1. Okay, that is only we did. Okay, for that let me explain once again. We are rationalizing this number, irrational number. What is that? 1 by 2 plus root 3. We are rationalizing the denominator. Whenever you rationalize the denominator, okay, 2 plus root 3 is there. Correct? You have to take the numbers with the same numbers you have to take. You just change the sign. If plus is there, you make it minus. If minus is there, you just convert it to plus. So 2 plus root 3 is there, you take 2 minus root 3. Whenever you multiply, you have to divide. So that is the reason I multiplied with 2 minus root 3 and divided with 2 minus root 3. So multiply 1 into 2 minus root 3, 1 into 2 minus root 3, and 2 plus root 3 into 2 minus root 3, which is in the form of a plus b into a minus b. You know the formula, a plus b into a minus b is a square minus b square. So a square, in the sense here, a is 2 and b is root 3. So 2 square minus root 3 square. So numerator remains 2 minus root 3 and 2 square is 4 and root 3 whole square, as we know here, root 3 whole square and root 2 whole square, square root will get cancelled. You will be left with 3. So 2 minus 3 is 1, 4 minus 3 is 1, sorry. So 2 minus root 3 by 1, which is again irrational. But we made this number, which is in the denominator, irrational number in the denominator, to make it as not the same number, we convert it, that's all. The whole, like number, we convert it as That's all. Okay? For that whole process system. Always remember, again I'm telling you, you should not keep any answer like this. It means the denominator should be a rational number. Denominator cannot be a irrational number. If it is like that, you have to rationalize and convert it. I hope you understood. Okay, these are very important for your future classes also. Okay, thank you, and please comment, like, share, and subscribe to our channel and support us. Have a great day for you guys.